Hello friends. This video is brought to you by mywayteaching.com.
We are already familiar with the Pythagoras theorem from our earlier classes. We have also proved it in class 9th. But here we will prove it using the concept of similar triangles. Before doing that, we need a particular result. So let us prove the theorem. Now before proving the Pythagoras theorem using similarity of triangles, first we prove this particular theorem, which says that if a perpendicular is drawn from the vertex of a right angle of a right triangle to the hypotenuse, then the triangles on both sides of the perpendicular are similar to the whole triangle and to each other. That means we have a right triangle ABC, right angled at B, and we draw a perpendicular from the right angle of the right triangle to the hypotenuse. Then the triangles formed, that is triangle ADB and triangle BCD, are both similar to the triangle ABC and they are also similar to each other. Let us start with the proof. Consider one of the smaller triangles and the complete triangle. Clearly, we can see that angle A equal to angle A is common. Also, we can see that angle ADB is equal to angle ABC, as both are 90 degrees. So we have proved the small triangle and the complete triangle similar by AA property. But how we will write the name of the triangles so that CPCT should apply? A will lie on A, D will lie on B, then the third vertex of the smaller triangle is ADB and the bigger triangle is C. So triangle ADB is similar to triangle ABC by AA criteria of similarity. Similarly, we can prove angle C equal to angle C, angle BDC equal to angle ABC. So, this small triangle and the whole triangle are similar by AA criteria, and we can write that triangle ABC is similar to triangle BDC. Why we are taking BDC? Because D should correspond to angle B, D should correspond to B, A will correspond to B, and C will correspond to C. Now from equation 1 and 2, we can see that triangle ABC is similar to triangle ADB and also ABC is similar to BDC. This will imply that triangle ADB is similar to triangle BDC. Hence we have proved that if a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then triangles so formed on both sides of the perpendicular are similar to the whole triangle and to each other. Here, important difficulty that everyone faces is, once the triangles are proved similar, how to write the ratio of the corresponding sides. Here is one way how you can simplify this. Draw a smaller right triangle such that it is also right angled at the same vertex where the bigger triangle is right angled. For instance, here B lies at this position, so a right angle lies at the same position in the smaller triangle. We can see that triangle ADB is right angled at D, so this becomes D. Also we can see that A is the common vertex to the bigger triangle and the smaller triangle which is similar to it. So our common vertex remains as it is. The third vertex of the smaller triangle is B, so B should lie here. Now it becomes very easy to write the ratio of the corresponding sides. We will have AB by AD equal to BC by DB equal to AC by AB. Let us do the same exercise for the other right triangle. We know that triangle BDC is also similar to ABC. So let us draw a right angle triangle which is right angled at the same point, and since the smaller triangle is right angled at D, we will name it as D. Now vertex C is common to both of them, so this becomes C, and the vertex that remains is B, so this becomes B, and now we can easily write the ratio. Since triangle ABC is similar to triangle BDC, we will have BD by AB equal to CD by CB equal to BC by AC. We shall use these ratios according to the requirement of the question. Now we come to the Pythagoras theorem. It states that in a right triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. So let us prove it using the previous theorem that we have proved. We have to prove that AC square equal to AB square plus BC square. By construction, we are drawing a perpendicular BD on the side AC. So we start with the proof. We have BD perpendicular to AC. Also from the previous theorem, we have triangle ADB is similar to triangle ABC by the theorem. Then if the two triangles are similar, then their sides will be proportional, implying that AD by AB should be equal to AB by AC. Let us recall that if two triangles are similar, then their corresponding sides are in the same ratio or they are proportional. So here AD by AB is equal to AB by AC. Now cross multiply this, we get AD into AC is equal to AB square. Let us mark this as 1. Now apply the similarity criteria to also the other triangle, that is triangle BDC is also similar to triangle ABC. So the corresponding sides are proportional, implying that CD by BC equal to BC by AC. This will give us CD into AC equal to BC square. Mark this as 2. Now adding the first and the second equation, we will get AD into AC plus CD into AC equal to AB square plus BC square. From the left hand side, we can take out AC common and we are left with AD plus CD equal to AB square plus BC square. Look in the figure, AD plus CD is same as AC, so this becomes AC into AC equal to AB square plus BC square, implying that AC square equal to AB square plus BC square. Hence we have proved the Pythagoras theorem. This theorem is also referred to as Baktun Theorem. Baktun was an Indian mathematician who had stated the Pythagoras theorem in 800 BC in the following form. The diagonal of a rectangle produces by itself the same area as produced by its both sides, that is, length and breadth. Now what about the converse of Pythagoras theorem? We have already verified in the earlier classes that this is also true. We now prove it in the form of a theorem, according to which in a triangle, if square of one side is equal to the sum of the squares of the other two sides, then the angle opposite the first side is a right angle. Here we are given a triangle ABC in which AC square is equal to AB square plus BC square, and we are required to prove that angle B is 90 degrees. To start with, we construct a triangle PQR which is right angled at Q such that PQ should be equal to AB and QR is equal to BC. Now from triangle PQR we have PR square equal to PQ square plus QR square by Pythagoras theorem. Let us substitute the value of PQ equal to AB and QR equal to BC here. We get PR square equal to AB square by BC square. This is by construction that we have done. But it was given to us that AC square is equal to AB square plus BC square. So from first and second, what we have is PR square equal to AC square, which implies that PR equal to AC. Now we can prove triangle ABC and PQ are congruent by SSS property. PQ is equal to AB, QR equal to BC and PR equal to AC. So the two triangles will be congruent and hence the corresponding angles will also be equal. So by CPCT, angle B, which corresponds to angle Q, will also be 90 degrees. So let us prove triangle ABC and triangle PQ are congruent. Quickly I will write AB equal to PQ, that is by construction. BC is equal to QR, also by construction. AC equal to PR, we proved above. So the triangles are congruent. By SSS congruency, implying that angle B equal to angle Q by CPCT, but we had taken angle Q equal to 90 degrees, so angle B is also equal to 90 degrees. Hence we have proved the converse of Pythagoras theorem.